Welcome to Programming with Professor Caleb. Today I'd like to introduce the concept of inheritance in object-oriented programming. When we think about what constitutes good code, one of the things we always try to avoid is duplicating code. We don't want two copies of the same or very similar code. There are a couple of reasons for that. First, we're just more likely to make mistakes if we write the same code multiple times. It's also easier to correct one copy of the code when errors are found. And when change is required because the business processes changed or the customer decided that he wanted something different, it's easier to make those changes if there's just one piece of code to change. As much as is reasonable, we want to reuse the same code for multiple purposes or situations. One way we accomplish that is something called composition. The idea here is that we're going to have one class use objects of a different class's instance variables in order to simplify code and avoid repetition. Consider this partial student class. As we look at it closely, we see some very similar instance variables handling the student's local address and their permanent address. This is, by the way, a very common issue. Some colleges have even more addresses stored per student. Having these basically duplicate instance variables will also require some duplicate code to manage these different addresses. We're going to have much the same actions with each address, but we're going to need different code because we have to access the correct address for each thing. We can reduce that duplication by creating an address class and having the student use address instance variables. That's what composition is all about, and it works great for has-a relationships. A student has an address or a couple of addresses. However, we have other situations where composition doesn't really make sense. Suppose that you were creating a faculty and student directory. So this slide shows possible student and faculty classes with typical kinds of information that we might see in a directory. Here we again see some duplication in the data, but there really aren't any has-a relationships here to exploit. However, there is an is-a relationship here. Both students and faculty are people, despite any rumors to the contrary about faculty. So here's a place where we can use inheritance. So what we can do is to have a person class that has the elements that are common to all of the people that we want to include in the directory. Then we're going to create student and faculty classes so that they inherit from the person class. This particular kind of arrow that I've used here signifies inheritance in UML class diagrams. So since student and faculty are pointing at the person, that is indicating that student will inherit from person and faculty will also inherit from person. What happens when we inherit is that the student class will have all of the data and capabilities of the person class, and the faculty class will as well. So if we were to look at a student object, it would have all of the person attributes as well as the attributes declared in student. However, it's important to understand that anything that's private in person is not directly accessible from student methods. So the first name, last name, and email address here were declared as private. So they're there in the student, but not accessible from student methods. However, the student class also has all of the methods that person provides. This is a good time to do some quick review of the access modifiers that Java provides. So we have private, which means it's visible to only this class. When we do a class diagram, we're going to see the minus sign or hyphen. We have public, which is visible to anything, and that's going to use the UML symbol plus. And then a new one that I haven't really talked about before is protected. So what that means in Java is it's visible to this class, its children, so the things that inherit from it, and its package. So of course we write Java classes in packages typically, and that's going to use the UML symbol, the number sign or hashtag or pound sign, whichever term you prefer to use for that. And then finally, we do have the default, which is no modifier. Simply means it's visible to the package. Don't use it. Just don't. Okay, I do want to talk a little bit about terminology because you're going to hear different terminology in relation to inheritance. And in fact, I use all of these different terms at different times. We have the person class, One way that we talk about that is that the person class is the base class. And in that case, the student and faculty classes would be derived classes. Another option is to talk about the person as the parent class, and then the student and faculty classes are child classes or children. And of course, that goes along with inheritance. Then we finally have the person as the superclass and the other two as subclasses. So all of those are very common ways to talk about this. Good to see that. Before we look at some sample code, I want to mention two important keywords we're going to use. So extends is what we're going to be using in the code to say, hey, I want to create this class and it is going to extend this other class. The other thing that we will need is super. So you can tell that's related to a superclass. And what it is a reference to the parent of the current class. So it's used if, for instance, we want to call something specific from the parent, and we'll see that a little bit in our demo. Okay, so I am here in Visual Studio Code, and I have a person.java class open, and this I will link under the video, also provide it directly for my current students. And I'll be using this hierarchy for a couple of videos, so you'll definitely want to follow along. So this is the person class we've been talking about. I have those three variable names that I had indicated for the person. We have a constructor that takes all three. We have a getter for the last name, and then a toString. Need a little bit of actual methods so that we can try out some of the different things that inheritance is going to give us. So now I want to create the student class that is a child of the person class. So let's go ahead and create a file, do a save as on that, and make it student.java. And I do want it to be a class, and I'm going to make it extend. So I say student extends person, and that's going to be the standard terminology for when we create a child of another class. Now that we have that, let's start working on creating the things that we had for our student. So our student had private string major and a private string class level. And now I need a constructor. And so I'm going to set up a constructor that takes in all of the data. But when I say all of the data, I don't just mean these two pieces of information, because a student also has name, both first and last, and email. So I'm going to actually take in all five of those things. So string, first name, string, last name, string email address, string major, and string class level. I cannot, it's tempting, but I cannot actually initialize these myself. If I tried to say this dot first name gets first name, I have an error here. And if I look at this error, we'll worry about the other error in a minute. It says it's not visible. I can't see it here. It is private in person. I can't do that. But there's an easy solution. So you may remember that when we're creating different constructors, we can use this as a call to a constructor, a different one in the same class. But we can do something different, and we need to do something different when we create a constructor in a child class. We need to make sure that we initialize the parent parts. So the way we do that is we use the keyword super that I mentioned, and then you'll notice we have a reference here to this first name, last name, email address. And those are the terms we've used, so we'll just leave that as it is. Then we can go on and worry about initializing the rest of the data that's actually defined locally. And there we go. Suppose that I want now, oh, I should make this public. Suppose that I now want to go ahead and provide a toString, but I'd like for the toString to have all of the fields in it. So it's public toString, public string toString. Here's our toString method. It's currently underlined because it needs to return something. Now, I could set things up in theory to actually get everything, but I don't have access to most of these things. I have a getter for the last name, but not for the first name. But this is a good thing because I've already done some of the work for this toString. All of these pieces are here for me. I don't need to rewrite them. I just want to use them. So what I'm going to do to make that work is I'm going to say, okay, well, string, just call it return value, or I guess return string works, and I'm going to say super.toString. Then I need to add the pieces that I want for the student class. So I'm going to then return string get return string plus the rest of what I want to do with major and class level. So putting in a new line because the other toString doesn't end with 1. So major plus major, and then let's throw in the class level. And then, of course, we need to go ahead and return our value. Return our return string. So let's go see how this works a little bit. I'm going to create a third file, and we'll call this test inheritance.java. And we'll just put a main in it. I'm going to have a person object and make that new person. And let's go John Doe. John Doe. And J Doe at some company. Oh, why do I have single quotes here? Sleeping through or something. Not even noticing what it's complaining about. I'd claim I'd been doing too much of other languages that use single quotes, but I really haven't. And there is a single quote value here. Okay, there's a person that I've created, and then I'm going to system.out.println John Doe's toString and system.out.println first one. Then let's go ahead and create a student, stu1, that will give new student, and this will make Mary Smith and M Smith at, really ought to make that somecompany.com, shouldn't I? At randomcollege.edu. Now, let's print Mary Smith's toString. do one. So let's actually first just run this. What did I, complaining about something. Oh, because I'm missing all the rest of the arguments. So let's make her a biology major, and she's currently a junior. There we go. Okie doke. Now let's run this. And we see that we get John Doe's toString and this information that just has the name and email. Then drag this up a bit. Mary Smith's information has her name and email, but then the biology major and the junior class level. Okay, I'm going to run this again, but in debug mode. And so we're going to set a breakpoint here. But in order for us to actually see some of what's going on, I'm going to also set breakpoints in our various methods. So I'm going to set a breakpoint right here in the constructor, and I'm going to set another breakpoint in the toString. And the reason for this is that this will allow us to sort of see what's going on as we're doing things. Let's run this. Actually, let's set the breakpoint even earlier so that we actually watch the creation of the person as well. So we'll debug. And we're going to switch over here where we can see things and look at our variables. So now I'm going to go into this, and we have these various items. We also have this, which currently has nulls for all the strings because we have not initialized them yet. And then we're going to go through and set each of these to the appropriate value. And that will pop us back out. Now we're going to go through, we print, we haven't set anything to break to really see what's going on there. Let's go ahead and go in, well, this will go in anyway, break for us. Now notice we have this call to super. So if we go into that, that is going to take us to the person. Now notice here, this is a student. It has all 5 of these, but we have some highlighting here in the debugger helping us understand that these are the pieces that are relevant here, that it knows about. Because this method knows nothing about class level or major. It's in the person class. So then as we walk through this, we will see the various variables in this student get initialized by this person constructor. And then when we come out, we're back up in the student one, and we can see the others get initialized as well. Now, similarly, when I go to print, of course, this print is going to call the toString, which I've set a breakpoint in, so we get there. So then that is calling the super toString first. So if we go into that, we're here. And so it is going to return all of those items. And so if we look, really gotten out of it yet, so we haven't actually set the return string. So now we have the return string set where we can really see it. Let me expand this so we can see it better. And it's not showing us the multiple lines, but will show us if we went and looked. That's all of the bytes that go into that string. Then as we move forward, return string will change. We can't really see that here because it's not showing us the new line, the things after the first new line. But of course, we return, we can see, and let's actually step on out of that, that what we printed did contain all of those things. So this is what inheritance is all about. The really cool thing here, if we get back to our own classes, is that I did this student, and I can do the faculty in a very similar way. And the work that is involved for these variables, I'm just reusing for both. So for the faculty.java, I would once again call the super for first name, last name, email address to get those initialized, and then take care of only the faculty pieces here. In the toString, I would call and get the name and email address handled by person before I step down and do the work that is specific to faculty. There are a lot of occasions where this is hugely valuable. Thanks for watching. In the next video, we're going to look at a related concept called polymorphism.